Hello folks, welcome to the canal channel Jose. Today we got a video about a question that is being asked on our channel, and it's about why our cooling fan on our car, on our Tercel, never shuts down. And so it's always running. As soon as you open the key, the fan starts running. So today we're going to show you a couple things you can do to check what can be causing that. So that way you don't take it to the mechanic, to electrical shop, and then find out that it's a simple fix. So with that, let's get started. Before we start troubleshooting why the fan is always on, we want to explain to you that the fan, for it to work or stay on, there's two components that they work together to keep the fan on or turn it off, turn it on and turn it off. The first one is the temperature switch, which is in the thermostat housing. What that does, this guy is always sending ground to the relay, and the relay, once it stops receiving ground, and we're going to show you what we mean by that. So with that said, we got the structure to show you what we mean outside, and then what you need to look for inside, right in the engine compartment. And with that, well, let's get started. Okay folks, so we have a structure where the thermostat is. This is the switch for the fan switch right here. So we got this structure and it's bolted onto the head like this, right underneath the distributor. So you're looking for this sensor or this switch, and it's connected, and it has one prong inside. So we gotta disconnect it from down there, and then we're gonna troubleshoot from there to the fuse box. Okay folks, so as you can see, we have removed the air intake box to the motor so we can expose what we're looking for inside the engine or in the engine compartment. And we're looking for this sensor right here. As you can see, this is the distributor, and the temperature switch sensor for the fan or fan switch is right here. So we gotta disconnect it, and as you can see, it's just a one prong and it has a guide. So when you connect it, it goes one way. So what we're gonna be doing is we're gonna be putting ground right into this and see if the fan turns off while the key is on, just so we can see. If you have replaced that switch and the problem still persists, let's check if you send ground through here and the fan stops. So now what we do is we grab our connector for our fan switch, we put a wire right into it, you open the key and you add ground to it and see if the fan stops. So if we want to see if by adding ground straight to it from the battery, it stops the fan from running. So let's do that now. So now you turn on your key and your fan automatically starts running. So what we do now is we grab our wire and we get one side connected to the connector that goes into the fan switch. So we get that in there, and the other end we're gonna connect it to ground. So as soon as you connect it, let's see what happens. So the fan stops running. So this means that if your problem stops when you do this, the problem is between the connector and the sensor or the fan switch. Even if you put a brand new fan switch, the connector is not connecting straight to the switch, and that's why it's always running. So what about if that didn't stop the problem? If your fan kept running when you do this. Now you have tested and you have put ground to the connector, and then the fan didn't react to anything. Second test, which is continuity, we're gonna test from the connector all the way to the fuse box to see if the wire has a break anywhere in there, because sending ground, it could have been just okay, it's not this, but we're gonna use a multimeter to find out if the wire has a break anywhere between the sensor to the box. So now using our multimeter, we're gonna set it in continuity right here, and we're gonna be using our testing leads to test at the connector, the sensor connector, and then we're gonna go in the box and we're gonna test if there's a break from there to the box, and we're gonna show you that we connect there and where we connect on the fuse box. So now you get your test leads, and doesn't matter which one you connect at the one end. So you connect, could be the black one or the red one, you connect it to the connector, you make sure it's touching, and then the other side we touch it at the relay where it connects in the fuse box. So we're gonna show you where this one goes in. So right here on your fuse box, this is your relay to your fan, and we remove that. It takes a little bit of effort. It looks like that. And right on this corner right here is the connector or the lead, that the wire. So we test and there's continuity. And we have continuity. So that wire from that plug all the way to the fuse box has continuity, so we can disregard that as a problem. So we added ground through the connector to the relay, but we didn't notice any change. So then we went a step ahead and we tested for continuity with the multimeter, and that told us that the wire has no breaks, it's not broken, and there's a continuity from that end to this end. So the relay is receiving signal, and maybe the broken part, it might be the connector, the sensor, or this fan might be wired differently, that is not going to the relay. So that could be another thing. So one thing I want to say is that these tools, these multimeters, they can be really helpful in situations like this, because if you want to send signal from one side to another and you're not receiving signal, this tool can tell you if it's broken or not broken wire with a continuity. This is a very useful tool to have when you're working on your cars on the electrical side. If you have a fan running and you pull this relay out, that means that the relay could be stuck, and that's a bad relay. So after you did the first test and the relay in the fan kept running even with adding ground to it, that means that this relay could be bad. So we're gonna pull this relay while the fan is running to see if the fan stops, and if it doesn't stop, the fan then is wired somewhere else, not to the relay. So let's show you that. Okay folks, so we have the fan running, and then we added ground to the connector to see if the fan will stop, but then there was no reaction. So then we think that the relay is bad, so it's stuck. So we are gonna verify that by pulling it off while the fan is on, and if it turns off, that means that the relay could be bad, because we already figured it out that by adding ground over there, the fan kept running. So we pull this, and then you replace the relay and you put a new relay, and hopefully that's a problem. But if you pull the relay and the fan keeps running, that means that the fan is wired to somewhere else and not to the relay where it should be wired up. So if in that case, you gotta figure it out where those wires are going, so you can rewire it back to where it's supposed to be, so it works with the temperature of the engine. So that's gonna be troubleshooting where it's wired up to. So now we have the fan unplugged, or the fan switch unplugged. We're gonna plug it in, and as soon as we plug it in, the switch is doing its job. It's sending ground or negative to the relay. The relay stops the fan from running. But if you connect it or disconnect that and nothing happens, add ground to the connector and see if the relay reacts to that. And then if that happens, if any changes happens there, that where the fan stops, you might have a bad connection here. Or when you put the switch, you put Teflon on it and it's not doing ground to the head or the aluminum, so that way it's not grabbing negative and sending it to the relay. Because if you add insulation in there, it's like having no switch. So you want to check here if the problem is in the connector or is not receiving ground all the way from there to here. Well folks, this was a simple and basic testing that you can do at home to diagnose what's causing your fan not to stop from running. It's always on. So one thing I can say is that you always want to start from the components that if it's getting signal or it's not sending signal, and from there work yourself towards the relay, because it could be just a simple connection right at the sensor that is not making good connection in the metals, and then it looks outside that it's connected, but the inside can drive you crazy because it's connected, brand new sensor, and it's still doing it, it's not stopping. So you want to do is, like we said throughout the video, disconnect the wire, use a wire to send ground through the wire to the relay, and see if that makes a difference and if it stops the fan from running. If that's the case, then you might have a bad connection at the sensor, or the sensor, you put Teflon on it, and when you screw it on, it acted as an insulator, so it's never gonna send ground to the relay. So if that didn't do any changes, if you did all those tests and nothing changed, unplug your relay and see if the fan stops. If it doesn't stop, then it might be wired straight to somewhere else and not to the relay, and that's why it's always on. So hopefully this video is useful, so you can use this and give you an idea what can be causing this problem on the fan that is always running. So for those viewers that are watching our video and haven't subscribed to our channel, please subscribe. If you like this video, give us thumbs up, share it, and we'll see you soon with more videos here en el canal El Chano Jose.